Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture series on derivative or differentiation. Right now we are going with the derivatives of standard inverse trigonometric functions. Standard inverse trigonometric functions in which we have to get the consideration. First of all, if y is equal to sine inverse x, it is a standard inverse trigonometric function. Here it is a domain of that function. That means a domain of that function is minus 1 to 1. Minus 1 to 1, that means value of x in between minus 1 to 1. At that time the value of y is in between minus pi by 2 to pi by 2. That means in this consideration, this inverse function is 1 1 and on 2 also, and therefore this is a part of your whole set. It is a part of our rational number set. Minus 1 to 1 for x value, you will get the value of y in between minus pi by 2 to pi by 2. Then we have to prove the consideration of dy by, then we have to prove here dy by dx is equal to 1 divided by square root of 1 minus x square, and mod of x is less than equal to 1. Why it is considered here? Because if we have to get the consideration of mod of x is less than that one, then 1 divided by something is here, and which gives the value less than 1, which gives the value less than 1 and greater than minus 1 is here. And therefore first of all we have to get the consideration of this proof of that function or proof of that consideration. We have to given that here, given that y is equal to sine inverse x, y is equal to sine inverse x. That means you will get the x is equal to sine y, x is equal to sine y, because we know that the y is the function of x. Inside this consideration, y is a function of x. Right now here x is equal to sine y. Inside this consideration, x is a function of y is here. X is a function of y is here. What does it mean? Here when value of x is changes, at that time you will get the change in value of y. That means y is a dependent variable and x is an independent variable. Right now here we will get the consideration of y, value of y is changes. At that time you will get the value of x is changes, and at that time you will get the consideration of value of x is depend on value of y is here, and therefore x is the function of y here, and therefore you have to differentiate or taking a derivative of x with respect to y here, and it is nothing but dx by dy is equal to the derivative of therefore derivative of y, derivative of x with respect to y, dx by dy. That means dy of sine y is here. We know that the standard derivative is nothing but a dx of sine x is equal to cos x. By using this formula, derivative of sine y is nothing but a cos y is here. Derivative of sine y is nothing but a cos y is here. Right now we have to get the consideration of this cos y is written like that one. That means plus minus square root of cos square y is here, and therefore it is nothing but a plus minus square root of 1 minus sine square y. How it is possible? By using the formula sine square theta plus cos square theta, it is equal to 1. What does it mean? First of all we have to get the consideration of theta is replaced by y, then you will get the sine square y plus cos square y is equal to 1, and therefore by using this one you will get the consideration of cos square y is equal to 1 minus sine square y, and putting those value inside this dx by dy, you will get the plus minus square root of 1 minus sine square y is here, and therefore you will get the dx by dy is equal to plus minus square root of 1 minus sine square y, but sine y is equal to x, and putting this value inside this, you will get the dx by dy is equal to plus minus square root of 1 minus x square is here, and dx by dy is equal to 1 minus x square. Cos y is positive, and therefore it is present in a first or fourth quadrant, and but cos y is positive and y lies in first or fourth quadrant as minus pi by 2 is less than y is less than pi by 2. That means you will get the value of cos is positive when y is lies between minus pi by 2 to pi by 2, and therefore you will get the dx by dy is equal to square root of 1 minus x square only. And we have consideration of, we have dy by dx is equal to 1 divided by dx by dy. Putting the value of dx by dy, that means square root of 1 divided by 1 minus x square here, you will get the dy by dx is equal to 1 divided by square root of 1 minus x square. Dy by dx is nothing but a 1 divided by square root of 1 minus x square is here, and this is nothing but a proof of this derivative of standard function. That means y is equal to sine inverse x, because here to get the consideration of dx by dy is a positive taken here, because cos y is positive and y lies inside the first and fourth quadrant. We know that the consideration of first quadrant all ratios are positive, in second quadrant all sine ratios are positive, in third quadrant we get the cos ratios are positive, and here you will get the tan ratios are positive, and here you will get the cos ratios are positive. And that means in first quadrant and fourth quadrant you will get the positive value of cos, because all ratios are positive here, and cos ratio also positive here. That means you will get the, we start from the 0 here and you are going in anti-clockwise direction, you will get the pi by 2 is here, and you will going with a clockwise direction, at that time you will get the minus pi by 2 here. It is nothing but a concept of direction angle, because direction angle it is a, in anti-clockwise direction you will get it as a positive, and clockwise direction it gives a negative, and our value of y is lies between minus pi by 2 to pi by 2. That means the cos ratio is positive in those quadrants, and therefore our dx by dy is not minus, it is only plus, and therefore you will get the dx by dy is equal to square root of 1 minus x square. And by putting those value you will get the consideration of this one, and by using this consideration dx of, we know that y is equal to sine inverse x is equal to 1 divided by square root of 1 minus x square is here, and this is your one formula related to inverse function. Now we are moving with the next derivative of standard inverse trigonometric function, where standard function is y is equal to cos inverse x. X is in between minus 1 to 1 and y is in between 0 to pi. Then we have to prove that dy by dx is equal to minus 1 divided by square root of 1 minus x square is here. Right now we have to prove it like that one. We have y is equal to cos inverse x. That means y is a dependent variable and x is an independent variable. X here y is a function of x, and therefore you have to take the derivative of y with respect to x is here. Right now you have to take the inverse of that function is nothing but x is equal to cos y. That means x is a dependent variable and y is an independent variable. Right now x is a function of y, therefore derivative of x with respect to y. Derivative of x with respect to y is taken as dx divided by dy is nothing but derivative of cos x is nothing but a minus sine x, and therefore derivative of cos y is nothing but a minus sine y is here, and therefore you have to take the consideration of minus. This minus is a separate one from that sign, and therefore inside the bracket plus minus square root of sine square y is considered here. Sine square y having the root is nothing but a sine y, but it is a positive or negative. It is considered by using your domain or codomain is here, and right now we have to put the value for that. Sine y is nothing but sine square y is nothing but a 1 minus cos square y. 1 minus cos square y, and we know that but x is equal to cos y is here, and therefore dx divided by dy is equal to minus inside the bracket plus minus square root of 1 minus x square is here. 1 minus x square is here. Now what is the sign of that value, plus or minus? It is depends on the consideration of value of y, where is in between which quadrant. Now we have to take the consideration of first quadrant, second quadrant is here, third quadrant is here, and fourth quadrant is here. In the first quadrant we know that all trigonometric ratios are positive. In second quadrant we know that the sine trigonometric ratio is positive. In third quadrant tan trigonometric ratio is positive, and fourth quadrant cos trigonometric ratio is positive. Right now we have to start from the positive x-axis, and we measure the angle for 0 is less than y is less than equal to pi. That means you have to move in anti-clockwise direction. It is taken as a positive, and it is moved from here to here. That means it is a pi, and it is a 0 to pi. That means our ratio is nothing but a sine ratio, and y in between these two quadrants, that means first quadrant and second quadrant. Therefore we say that sine y is positive for all values in between 0 is less than equal to y is less than equal to pi, and therefore sine y is a positive, and therefore we have to take this ratio as a positive, and therefore dx divided by dy is equal to this minus sign is outside sign, and it is taken only positive. That means plus square root of 1 minus x square is here, and plus into minus is equal to minus square root of 1 minus x square. This is the value of dx by dy. Right now according to derivative of inverse function, derivative of inverse function, dy by dx is equal to 1 divided by dx divided by dy, and therefore you will get the value of this dy by dx is equal to 1 divided by minus square root of 1 minus x square is here, and therefore you have to say that minus 1 divided by square root of 1 minus x square is here, and therefore you can say that dx of what is the value of y is nothing but a cos inverse x, and therefore derivative of cos inverse x is equal to minus 1 divided by square root of 1 minus x square is here, and this is your another formula for trigonometric standard inverse trigonometry function, that is y is equal to cos inverse x, and cos inverse x having the derivative minus 1 divided by square root of 1 minus x square is. Right now we are moving with the next standard inverse trigonometric function is y is equal to cot inverse x, and x is belongs to R, that means a rational number set, and y is in between 0 to pi. Then dy by dx is equal to minus 1 divided by 1 plus x square is here, and right now we have to get the consideration of we have y is equal to cot inverse x. That means y is a dependent variable and x is a independent variable. That means that means y is the function of x. Therefore, derivative of y with respect to x is now. Right now we have to take the inverse of that function is nothing but x is equal to cot y. X is equal to cot y. That means here x is a dependent variable and y is an independent variable. That means x is function of y, and therefore derivative of x with respect to y is taken here, and it is nothing but dx by dy. Dx by dy is nothing but we know that the cot x having the derivative is a minus cosec square x, and therefore cot y also having the derivative is nothing but a minus cosec square y is here, minus cosec square y. Right now you have to take the consideration of minus inside the bracket. Cosec square y is nothing but a 1 plus cot square y. We know that the formula for the consideration of 1 plus cot square theta is equal to cosec square theta. This is one identity, and from that identity you can get the consideration of 1 plus cot square y is equal to cosec square y, and by using this value of cosec square y inside the derivative you will get the consideration of 1 plus cot square y is here, but x is equal to cot y. X is equal to cot y is here, and therefore dx by dy is equal to minus inside the bracket 1 plus x square is here. 1 plus x square is here. Right now, what is the sign for the cosec square y? Because it is a square of one quantity, that means cos y. It is a square of cos y, and therefore whatever be the value of cos y, it is a positive or it is a negative. Whatever the value of cos y, I repeat again, whatever the value of cos y, it is a positive or negative, square of that cos y is nothing but a positive, and therefore this minus sign into positive value is nothing but a negative value. And by now according to derivative of inverse function, that is dy by dx is equal to 1 divided by dx by dy. Putting the value of dx by dy inside this derivative, you will get the consideration of dy by dx is equal to 1 divided by minus 1 plus x square is here, and it is nothing but 1 minus 1 divided by 1 plus x square. 1 plus x square, and you will get the consideration of d dx of what is the value of y is here. Value of y is nothing but a cot inverse x, and derivative of cot inverse x is nothing but a minus 1 divided by 1 plus x square. Here we remember that the cos, whatever the value of cos y is here, value of cos y is a negative or positive, square of that value is nothing but a positive, and therefore it is taken as a positive everywhere, and you will get the derivative of standard inverse trigonometric function, that is a cot inverse x is nothing but a 1 minus 1 divided by 1 plus x square is here. Now we are moving with the next standard inverse trigonometric function is nothing but tan inverse x. Y is equal to tan inverse x. X is in between R, that means domain is nothing but a rational number set, and y is in between minus pi by 2 to pi by 2. This is the codomain of that function. In this two consideration, domain and codomain, this tan inverse or inverse trigonometric function is nothing but 1 1 and on 2. Therefore the function of that is nothing but, and then you will get the derivative of that y dy by dx is equal to 1 divided by 1 plus x square is here. Now we have to prove the consideration or proof of that consideration is nothing but we have y is equal to tan inverse x. Once again I am repeating here is that y is a dependent variable and x is an independent variable, and therefore y is the function of x, therefore derivative of y with respect to x is taken here. But right now we have to take the inverse of that function, is nothing but x is equal to tan y, and here x is a dependent variable and y is an independent variable. That means x is a function of y, and therefore derivative of x with respect to y is taken here, and it is nothing but a dx by dy is equal to the derivative of tan x. Derivative of tan x is nothing but a sec square x, and therefore derivative of tan y is nothing but a sec square y is here. Sec square y is written like that one, 1 plus tan square y. 1 plus tan square y. It is taken from the consideration of 1 plus tan square theta is equal to sec square theta, and by replacing the theta by using a y, 1 plus tan square y is equal to sec square y is here, and therefore you will get the 1 plus tan square y. But we know that x is equal to tan y is here, and therefore dx by dy is equal to 1 plus x square. And right now we have to once again consider whatever be the value of sec y. Sec y value is a positive or negative, the square of that value is nothing but a positive, and therefore once again I am repeating the consideration. Sec y value of sec y is a positive or negative, the square of that sec square y is nothing but a positive, and therefore you will get the dx by dy is equal to 1 plus x square. It is a positive value, and therefore you will get the consideration of according to derivative of inverse function dy by dx is equal to 1 divided by dx by dy, and therefore value of dx by dy is here, and by putting the value of dx by dy is nothing but a dy by dx is equal to 1 divided by 1 plus x square. 1 divided by 1 plus x square, and what is the value of y? Y is nothing but a tan inverse x, and therefore dx of tan inverse x is equal to 1 divided by 1 plus x square is here, and this is your derivative of tan inverse. That means one another standard inverse trigonometry. If you like this video, please subscribe my channel and press bell icon to get next notification related to that lecture series on derivative. Thank you.